Hello and welcome back to AutomateOps. Today in this video, we are diving into one of the most powerful features of modern Ansible automation called dynamic inventory. If you have ever struggled with keeping static inventory files up to date or ever wondered how to manage the large cloud environments automatically to stay in sync, then this session is going to be a game changer. So let's get started. So in this slide, before we jump into the technical details, let anchor ourselves with the basics. Dynamic inventory is all about real-time automated discovery of your infrastructure. Now, instead of manually updating the host list, Ansible queries live sources like AWS, Azure, GCP, CMDB, or custom API. So your inventory is always current. So let's understand why that matters. At the heart of the dynamic inventory, it's called simple promise. You give me the host that actually exists right now, and it retrieves the real-time host information, integrates with the cloud providers, automatically groups servers through tagging, and ensures that the security by eliminating the stale host. This becomes essential in environments where servers scale up and down, like auto-scaling group in AWS. So no outdated host names, no manual updates, just clean, accurate, and real-time infrastructure data. That's the core power of dynamic inventory. Now, coming to the next concept, types and requirements and overview. Like now that we know why, let's look at the how. Dynamic inventory come into two major forms, script-based inventory and plugin-based inventory. Both serve the same purpose, but they work very differently. So let's break them down. Now coming to the script-based and plugin-based approaches. First, we have the script-based inventory. It uses a custom executive script, usually Python, that outputs JSON where Ansible requests it. Script-based inventory is perfect when you are dealing with custom APIs or legacy system. Then we have plugin-based inventory, where this is my personal favorite for cloud automation, and we will do all the particular labs in the next module using this plugin-based inventory only. This plugin-based inventories are built in, well-tested, and are very easy to configure for Azure, AWS, GCP, Kubernetes, VMware. Plugins do all the heavy lifting. And in real-world setups, a hybrid approach is common. So, which is the combining for legacy systems and plugins for cloud services. So, plugins for cloud and scripts for everything else. Now, what is the requirements for building a dynamic inventory? To work currently in a dynamic inventory source, we whether it's a script or plugin based automation, we must follow Ansible's expected structure. A script must accept hyphen hyphen list and hyphen hyphen host arguments, returning the JSON data. And it includes a special underscore meta section, this one, containing the host variable and performance optimization. Why there's underscore meta important? Because it dramatically boosts the performance, especially when you have hundreds or thousands of host plugins. On the other hand, rely on YAML-based configuration and handle most of the heavy lifting automatically. But they follow the same output structure internally. Now, we have now understood the requirements. Let's go deeper into implementation and performance tuning because real-world automation depends on speed and reliability. Coming to a Python scripting example, here is a practical Python-based dynamic inventory example. The script use argparse for inventory and JSON to output the inventory. and then logging to track execution even generates fake host for scalability testing. A well-designed script never prints error to std out, and because Ansible expect pure JSON output, error must go to stderr while logs go to separate files. So let me show the code here, but here we will not do any kind of lab today. I'm just showing it for the example purpose. Okay, so let me show it. Here we are. If you have seeing the screen, so this is an example. I have created an inventory. It's a Python part. Then I'm logging all this information here, and then I'm defining the inventory data. Like here we have defined three servers. This localhost is like our earlier example. It is using the local connection versus Ansible user. Same for target one. I'm pressing the private IP address, Ansible user information. What is the Python interpreter version? What is the private key file? Same for target two. I provided this information. Now I'm creating the groups on the run. I'm creating the control group. I'm creating the target group. And then I'm using the Ansible SSH common arg. There's a strict host k checking no. So it means I'm not checking any kind of host here. Here also, what I'm doing, I'm doing a creating a fake host which is 100 in numbers using the loop, and I am moving this under the fake host group. Okay, so this is the line. It is getting all this, taking this fake host here, and it is assigning this to the only. Now I'm building the full inventory here using the host vars variable, and I am using a for loop to add everything inside the inventory with the names host, and this host file will take the information from this information only, control target and everything. And then what I'm doing, I'm building the host var information. I'm adding some parser information to all log all this information. So overall, it's a very small but very powerful example of dynamic inventory using Python. Let's go back to the theory now. All right. So this particular example here, while why I should optimize this underscore meta and caching. Two optimization we have that truly transforms the dynamic inventory performance. The underscore meta dot host var section. This stores all the host variables in the single directory and prevents repeated calls to rebuild the host data using this single dictionary only. Second is inventory caching. By enable caching in Ansible.cfg file, it avoids repeatedly querying the cloud APIs, saves time, saves cost, avoiding real limits. The combination of caching and underscore meta, it provides a very fast, scalable, and enterprise-grade automation. Okay. Now, coming to the practical usage or real-world scenarios. So, moving to the theory into practice, we can show that how this move from theory to practice, how does dynamic inventory actually help teams to production environments. Let's explore some real case situation. So let me give you an example. Here is an AWS EC2 plugin we are using. So this plugin is one of the most commonly used dynamic inventory providers. It retrieves the EC2 information using IAM roles, credentials, all this information. What is the tags? What is the availability zone? What is the type of instance? What are security groups that this EC2 is associated? Then it provides the visualization safety also, that how much secure the particular EC2 instance is. And then it's a approach cloud native automation benefits are also there because dynamic inventory reduces this manual maintenance, any manual updation of the static inventory. enhances reliability, aligns with the scalable cloud operation. So we this makes the automation safer because we are always targeting the target server. So let me, if not sure whether it will run or not, but let me show a very basic example here. Let me go to that particular path. If you see my screen, so here what I'm doing, I'm trying to give you example that how that looks like. So Ansible inventory. Don't worry, we will discuss all these things in very detail inside the next particular session. I'm just trying to give you an information that how this looks like. So in this inside this AWS EC2, I've tried to create a graph. What are the names? What are the IP addresses? Because it's a Amazon EC2 instance. Their host name looks like this only. I've not renamed them also. So just wanted to give you an idea how the dynamic inventory looks like. Okay. Now I'm going to the particular example web use case of a production web server here. So it's a suppose we want to patch some production web servers, and this is not a single patch. There are n number of servers mentioned over here with static files, uh, and it becomes very error prone. So, but with dynamic inventory, we can simply target that the environment is equal to production, role is equal to web server. So, Ansible automatically discovers the correct instances. If these are hosted inside Amazon cloud, so if we use that AWS plugin, we can clearly find it out what all servers are in production, what all servers having the role of web servers, and Ansible will patch those web servers only under the production environment. It works beautifully for blue and green deployments, rolling updates which are targeted for the web servers only, just for the sake of example, and those are in production. Canary releases. It keeps automation very precise and safe every time. Now coming to the best practices and quality assurance. So powerful systems require careful design. So let's walk through the best practices for building reliable dynamic inventory. So error handling is absolutely critical. So your script or plugin must output only JSON on std out, and then it should send errors to an stdr. We can use structured login and pass validation checks before the deployment. And plugins should also be tested for invalid filters, misconfigurations, and API real limits. Above all, dynamic inventory output must be idempotent. Same input, same results. This keeps the automation predictable and safe. All right. So this is a very practical workflow. We will discuss all this point, how dynamic inventory can be scripted. What are the cloud inventory plugins with filters, grouping, and caching? How to optimize the performance using underscore meta host bars, enhance the automation scalability, and we can apply the automation in productions like that, patching servers, like we have discussed in the previous example. If we want to install our patches only the web servers under production environment, we can do that using the tagging. So now we have exploited uh, the foundations and workflow optimization, practical use case of dynamic inventory. So now let's bring everything together to summarize end-to-end workflow for AutomateOps. So what we will do in the next section, that we will build Python-based dynamic inventory script. We will learn configuration of cloud plugins like AWS EC2. We'll enable caching and meta for performance, and we'll apply the automation like patching and deployment. So in a nutshell, dynamic inventory is the backbone for modern automation. It keeps the infrastructure accurate, fast, completely hands-free. So thanks for watching. If you found this helpful, don't forget to like, subscribe to AutomateOps, share this information with your team members, colleagues who are interested in Ansible automation. See you in the next video, which is going to be very interesting because going to discuss the lab. We are doing some practical examples there, just like we discussed. So thank you all. Thanks all for watching. Happy automating. Thank you. Bye.